Have you ever wondered how reconstructive procedures like plastic surgery actually work? Not from like a, beauty angle, but from a biomedical engineering standpoint?
Today, we're breaking down the biology around tissue engineering and plastic surgery, specifically what that makes reconstruction possible. No medical advice, just the science and engineering behind it.
Reconstruction procedures can involve many different types of bioengineering methods. For example, tissue or skin removed from one part of the body and transplanted into another is a common method called skin grafting. These can be done due to trauma, disease, or unhealed injuries.
And this is where biological engineering comes in. Those tissues are alive. In order to survive in the new location, they need to reconnect with the body's blood supply. That can be done through new vessels and connected to the transplant tissues.
The process goes like this. The skin tissue is transplanted into a new part of the body from a prior location that's usually hidden. The new skin is either secured with staples or stitches, or meshed into the donor site, then covered with a dressing to heal.
The goal is for the tissue to receive enough oxygen and nutrients to stay alive. That is tissue engineering at work. Firstly, we're going to go over how the cells live and survive in the new cells.
The survival rate for transplanted tissue depends on how well it establishes a blood supply. Skin grafts have a high survival rate because they are almost immediately reconnected with a blood vessel in order to get the necessary nutrients.
But with fat grafts, on the other hand, only about 50 to 70% of the fat that gets transferred actually survives. This is because the cells need oxygen quickly. If too much fat is injected into one spot, the cells in the middle don't get enough oxygen and they die.
So surgeons will inject small amounts in multiple layers. It is literally based on diffusion and vascularization, which is new blood vessels going into transplanted tissues using the same principles that are used in tissue engineering labs. Now, relating back to reconstructive surgery, one of the more common methods is with silicone implants.
In essential reconstructive surgery, silicone is often used. These procedures engineer materials to restore areas affected by injury or deformities.
Medical grade silicone is flexible, durable, and biocompatible, so the body can tolerate it long term.
It has an elastomer shell, which is made from polymer, which have elastic properties. This is built to withstand years of movement and pressure, which is crucial to when silicone supports are repaired in reconstructed tissue. Does the implant integrate well once it's surgically added?
I'm aware that one of the major engineering challenges is biocompatibility. Will the material be able to stay safe inside of the body?
Engineers test implants and transplants for mechanical strength, chemical stability, and how the body reacts over time. They do the same for foreign tissue implants to make sure that the body is compatible with what it's receiving.
Surface texture will also play a role. Smooth versus textured silicone behaves differently in the body, which can change both stability and the way the scar tissue will develop. Smooth silicone moves more freely within the body, while textured silicone provides more grip for the body to grab onto.
All of this is part of designing the same biomedical devices.
So, are there any improvements that can be made to enhance plastic surgery?
Why, yes, of course. A new method of plastic surgery is tissue engineering, which is where surgeons use a 3D scaffold to make a template for new cells and have old cells join in the new structure.
Wow, that's awesome. So how does this improve any of the possible negative side effects of traditional plastic surgery?
Well, you see, it has a better chance to be compatible with the donor, as well as it has a more natural look than traditional plastic surgeons. In addition, this can be 100% customizable to the patient's see fit.
That's awesome. Sweet, dude. Thank you.
It's clear that plastic surgery and tissue reconstruction has its positives and negatives, but there are enough benefits that come from these procedures that they're still used, built upon, and learned from today.
Thank you for your time, folks. I appreciate it. Please subscribe to our YouTube channel, and for those of you interested, this is a crossword. If you paid attention to the video, the words are said